Okay, section 9.1 is where we are going to simplify rational expressions. This is where we're going to have an expression, and we're going to be factoring a lot of things in order to see what things would end up canceling out. So here is my first example. So first thing we want to do is we want to factor completely the top and the bottom and see what it ends up coming up with. So for the top, I went ahead and did my a times c on the top of my x. I did my b on the bottom. So I need factors of 24 that are going to give me -2. So I would want to use -6 and +4 because they would multiply to -24 but add to -2. So in my set of parentheses, I would have x minus 6 and x plus 4. For the bottom, I see a greatest common factor that I would want to take out first. So I'm going to divide everybody by 2x. And when I divide by 2x, I'm left with 1x squared plus 3x and minus 4. Now what I'm going to do is I'm going to do my x for just this piece that's inside my parentheses. So I need factors of -4 that give me 3. So I'm going to have +4 and -1. So I would write my greatest common factor out in front. Then I would have x minus 4 x plus 4 and x minus 1. Now what I'm going to do is I'm going to write out my new fraction in my factored form. So on the top, we found that it factored to x minus 6 and x plus 4. On the bottom, we found that it factored to the 2x and the x plus 4 and x plus 1. Now that it's in factored form, I can see where I have those common factors, and those guys are just going to cancel each other out and remove themselves from the expression. So I'm left with, on the top, x minus 6, and I'm left with, on the bottom, the 2x and the x minus 1. Now, the other part of this question is asking you to figure out when the original expression is undefined. So I am undefined when my denominator is equal to 0. Now, please remember to always use the original, so not the simplified version, but this. So what you're going to do is take each of these denominator factors and set them equal to 0. So 2x equals 0, x plus 4 equals 0, and x minus 1. And then you're just going to solve them. So I would be undefined when x is equal to 0, x is -4, and x is +1. Because again, undefined would mean when I plugged in these values, it would give me a 0 in the denominator, and you can never divide by 0. Okay, pause the video and see if you can do the next one. On the next one, you would have wanted to factor the top. So x squared minus 36 means that I would have had -36 on top and a 0 in the denominator. So this is a difference of 2 squares. So I need the same number, and one of them is going to be positive, one of them is going to be negative. So I would have x plus 6 and x minus 6 for my two factors. On the bottom, I would have -66 on the top of my x and -5 at the bottom. So I would want to use 6 and 11 to get me to 5, and then I would want to make my 11 negative. So x minus 11, x plus 6. So then I'm ready to put it into my factored form. So my top became that, my bottom became that. Then I can cancel out the ones that are the same. So I remove those and I get this. And then I have to specify where I'm undefined at. So that's where you're going to set the denominators equal to 0 and solve. Okay? All right, on the next ones, we're just going to keep getting a little bit bigger and a little bit bigger. So on the next one, you're going to see some multiple variables within your expression. And you're still going to do the same things where you're going to want to factor it as much as you can. So what I did was on this top part right here, I went ahead and took out an x from both of those. So I could see I had a greatest common factor, and that's how I rewrote it. On the bottom, I didn't really see anything that I could take out as a greatest common factor. The next thing is I kind of noticed that these two here look very similar. And so I'm trying to figure out what could I do in order to make them become the same, because I see that they both have a 5y and they both have a 6x, but they're just opposite signs of each other. So to make them become the same signs, what you can do is just take one of them and multiply by -1. And that's what's going on this next step, is that I'm going to take that top expression here and I'm going to multiply by -1. So that'll flip their signs. And then I'm going to switch the order just so that it matches the same one with the bottom. Okay. So if you kind of have that gut feeling that something is the same, typically you can just check by looking at their signs. And if their signs are just opposites, that means you can multiply by -1. So I took that -1 and put it out front there. This guy right here became 5y minus 6x. And then I still have the other one. And then on the bottom, it did not change. So now you'll notice I can remove these two here. And then I'm left with that -x and then x plus 2y, x plus y. I just wanted to show you that you can also put that negative out in front of your fraction and it can be rewritten either way. So either out in front or you can put it up there in the numerator. All right, pause the video and see if you can try this next one. This next one's a little tricky. So that top part I can see is a difference of 2 squares. So I would have taken my -4 and my 0, and I would have made it become +2 and -2. And then if you drop your first term, drop your last term, I always just throw one of each on that middle, and then you can factor it out. So I would take out my greatest common factor of these two, which would be 2x, and I'm left with 2x minus y. This, I just took out 1y, so I'm left with that. So you'll notice that it becomes 2x in the first part and 1y on the second, and then you just change your signs. So I typically don't go through this whole process because I can spot a difference of 2 squares and jump right to my shortcut of the answer. So if you can do the same, just do the square roots of them, and that's what you end up putting here with opposite signs in between. Okay, so then what ends up happening is on the top, it factored to that, okay? And then on the bottom, there was nothing for me to factor. Again, my gut is telling me that I've got something that is the same, and so I notice that these two are the same, but just opposite signs. So +2 is -2, -y is +y. So I can take out that -1 like we did before. And then I can also switch around the order if I want to for it to completely match, okay? So this first one stayed the same, and then I did the second one where I switched the order and I switched the signs, and I took that -1 out. So now I can remove my factors that are the same. And so I get that -1 out there, and then 2x plus y, and on the bottom 4 plus x. So again, if you notice something that looks similar or almost the same, try doing that -1. And if you want to completely step it out to make sure that it works out, this is how you would completely step it out. So times it by -1, then you would get this, and then you would want to switch the order to see if it matches the same. Okay, so that takes care of day 1 that we're going to do. Now we're going to move on to day 2. And in day 2 is where we're going to start multiplying and dividing some expressions. So remember, when you're multiplying fractions, you just multiply straight across when I multiply fractions. When I'm dividing fractions, remember you have to keep, change, flip, right? So when I'm dividing fractions, keep, change, flip. So I have to do that extra step in order to multiply those guys. So that's what we're going to practice with these expressions. Maybe. There we go. All right, so on this first example, we are just multiplying. So when you're multiplying fractions, like I told you, you're just going to multiply straight across. Okay, so I'm multiplying like terms. So I've got 3 times 12. I've got x to the third because I'm adding my x's, and I got 1y. multiply my bigs, add my x's, add my y's. Now I'm going to look for like terms to simplify. So these guys are like terms, these guys are like terms, and these guys. So thinking about those, I'm going to simplify 36 over 72. I'm going to subtract my x's. So if I take away one x here and take away one x there, I'm left with two x's on the top. If I take away one y here and take away one y there, I'm left with three y's on the bottom. That's how you're getting that answer. Pause the video and try this multiplication problem. Okay, so on this guy, you would want to multiply straight across. So you should have gotten 60 x to the third, y to the second. And then over here, 45x, y to the fourth. You're going to simplify 60 over 45, so that's going to become 4/3. Subtract your x's, so x squared. Subtract your y's. Y squared gets left on the bottom because that's where you had more left over. Okay, so let's look at a division problem now. So remember, when you are dividing, you're going to keep, change, flip. So I am keeping the first, changing it to multiplication, flipping the second. So multiplying by that reciprocal. Once you've done that step, it is the same as what we just practiced. We're going to multiply straight across. So I've got 40 CD to the fifth. On the bottom, I've got 180 C to the fourth, D to the third. And then I'm still going to simplify like we practiced before. So this is going to become 2/9. This is going to become C to the third on the bottom. This will become 2 D's that are left on the top. Pause the video and try this last question here. So I went ahead and keep, change, flip. I also distributed this power of 3 to both of these just to make it a little cleaner without parentheses. So I'm going to times straight across. So I got 54, a to the second, b to the third, 18, a to the fourth, b to the fourth, and then I'm looking at like terms. So this becomes 3. This becomes a squared on the bottom. This becomes b to the first on the bottom. Okay, so if you also wanted to, you could not put that 1 on the bottom and just rewrite it like that. Okay, so in this curriculum, they also have you applying it with different word problems. So here's my word problem. The manufacturer that creates and sells rectangular planners wants to compare the areas of the top sections of two potential sizes of planners. For some given measure x, the area of the first planner is represented by that expression, and the area of the second planner is represented by that expression. Write and simplify an expression that represents the ratio of the area for the first planner to that of the second. So whenever you hear the word ratio, all that means is that it's wanting you to divide them, okay? So off to the side here, I was just writing it out for you to see that we're going to divide them, okay? So in this case, we're kind of backtracking. We've got to factor out those pieces. So I went ahead and wrote it out so you could see. So 50 on top, 15 on bottom. So I need 10 and 5 in here. So I've got x plus 10, x plus 5. Over here, I've got 200. And so I would need to use 10 and 20 in order to give me that 30 number on the bottom. So then I'm rewriting it so you can see my new factored form. Okay, so all I did was replace my factors here and my factors here. Now I'm going to keep, change, flip because it's division. And then what I like to do here is you can go ahead and multiply it all the way across, but you can cross cancel as well. So you know how we were removing straight up and down? You can also do that diagonally. So these x plus 2's would remove themselves and the x plus 10's. These problems become very lengthy after a while, so if you can kind of cut out some of the writing in these, that will help you because they do get very lengthy. So then I'm just left with the x plus 5 over x plus 20. All right, pause the video and see if you can do the next one. Now, I went ahead and gave you the formula for the volume of a prism. You're doing area of the base times the height. Fortunately for you, they went ahead and gave you the area of the base because it's a rectangle. So you are just multiplying this times the depth, which is just your height. Okay, so this is just a multiplication problem. Same as before, you're going to want to factor this out. So go ahead and do your x if you need to and find your numbers. So I would use 2 and 3. Same with over here. I would need to do factors of 3 that give me 4. And that's how I got this part. Again, these get lengthy in terms of paper-wise, so I would just go ahead and cross-cancel if possible. So I'm going to remove my x plus 2s. I'm going to remove my x plus 1s, and then I don't see anything straight up and down. So then I'm just left with 2 of those x plus 3s, or you can write it x plus 3 quantity squared. All right, last kind of problem we get to do are complex fractions. This is where you get to see a fraction within a fraction, and that's what this is all about. So here is your fraction. So you got a top and a bottom, and then you've got a fraction within that fraction. So here you've got more. So when you see these problems, please just think that this big division right here, that's just going to be your division bar. So think of it like you taking the top and dividing by the bottom. That's really all it is. And then you're just doing the same steps. So don't freak out when you see these things. So remember with division, we get to keep, change, flip. So that's what I'm doing here. Then we're going to start factoring as many pieces as I can. I see this is a difference of squares. So I went ahead and pulled out my greatest common factor, and then I also saw these were both squares. So square roots, and then do the opposites in between there. Okay, so I'm going to rewrite it just so you can see it for now. So I kind of did 2 steps at the same time here. So this piece right here became your 4, and then your x minus y, and your x plus y. Okay, so then I went ahead and multiplied straight across, so that's where my 12x came from, and then I rewrote the x minus y, x plus y. On the bottom, I just wrote them together with multiplication. Since there's a subtraction sign, please make sure you put parentheses around that, and then I just put it in front. Doesn't matter if you do front or the back side. Now I'm looking for greatest common factors. So I see the x minus y's are common, so those can be removed. I also see my x's are the same. They're going to cancel each other out. I also see my numbers, 12 over 6, will simplify. So that's where I got my 2 over 1. I had 1 y left on the bottom, and then your x plus y left over on the top. Okay, so complex fractions, still just division. So why don't you pause the video and try this last one. So once again, you've got that big division bar in between there. Okay, so just think of it like division. So I just rewrote it horizontally instead of vertically. Now I'm going to factor as much as I can. So these x plus 2's, I see I've got 2 of those there. And then I've got a 3 minus x over there. So I went ahead and keep, change, flip. But I also factored at the same time. So my x squared plus 14x plus 24 is over here. So I used 2 and 12 for that. So x plus 2, x plus 12. Okay, so that's where this changed out to x plus 2, x plus 12. Then I also did a greatest common factor on this one. So that became 3 and then x minus 3. So when I was keeping this, changing to multiplication, and then flipping those two so you can kind of bridge the gap there. I also went ahead and did one more step because I saw this and I noticed this over here. So I went ahead and did that -1 piece because I knew they would end up canceling. So that x minus 3 and that 3 minus x, those are going to end up being the same after you multiply by -1. So that's where this -1 came from. Okay, so I did -1 right here, and then I had positive x and -3 when I did that. So I did a couple steps at the same time just because, again, these problems are so lengthy. So I was trying to shorten the steps a little bit. So I'm ready to start cross-canceling. So my x minus 3s are going to remove, my x plus 2s are going to remove, and then I'm left with this. So I've got 3 and x plus 12 on top, a -1 and an x plus 2 on the bottom. All right, and that's where we're going to pause for section 9.1 with simplifying expressions.